Welcome to Global Information Security Society for Professionals of Pakistan.
I think they have now a newer version of top 10 that just recently came out. But for the purpose of this test, certification, they are focused on 2017. So we'll just quickly go through these vulnerabilities. First one is injection. So injection attacks refer to broad class of attack. It's not one attack. It's a class of attack in which a malicious actor sends untrusted command or input to an application. So input validation is the process of ensuring that all input fields are properly checked and approved by the application prior to processing the input. So basically what it means is that you have a username and password field, or maybe you have a field that is asking for your national ID card number. So that field should only take national ID card number and nothing else. We know, I think, correct me if I'm wrong, I think Pakistan national ID card number has 13 digits, right? So that field should enforce only 13 digits of input. It should not allow more than 13 digits, right? And it should only take numbers. It should not take, what they call alphabets, right? So those are the type of input validations that you can do to avoid injection vulnerabilities. Broken authentication is a vulnerability that allows an attacker to capture or bypass an application authentication mechanism. We have actually just recently done an assessment for Microsoft Azure. So one of my consultants, what we were able to find out is that the management plane of Microsoft Azure, once you log in, it generates a session, and we were actually able to capture that session and replay that session without the username and password, and that user was able to log in to management plane without the username and password by just replaying the session. So we found out a broken authentication mechanism, a broken authentication in Microsoft Azure portal, which we worked with Microsoft, and now it is fixed. So this was last year. So that's an example of broken authentication. Sensitive data exposure. Sensitive data exposure is exactly what it sounds like. So many web applications collect, store, and use sensitive user information. So data like user credentials, PII, and credit card data. So some of these applications do not properly secure the sensitive information, which can lead exposure to unauthorized parties. I'm not sure how many of you and how old are you, but when I actually started working with computers, 20, 25 years ago, the applications back then were not very sophisticated, and e-commerce websites, when they came out, what they did is, since security was not a big part of it back then, so the actual price of the items that they were selling was stored in a hidden field in a web page. And it was very commonly known at that time among various ICQs and various channels that if you look into the hidden fields, there used to be hidden fields. The actual price is written of that item is in that hidden field, and that field was modifiable. So we were able actually, if a price is maybe $10, we can change it to $1 and then send it back to the server, and we can get that piece of item for $1 because that's the price. So those are the things that sensitive information was disclosed like this back then because security was not part of it. So we were able to do that, but now that is not the case. It's different thing. So XML entities, an XML attacks occur when XML input containing a reference to an XML entity is processed by an application without thorough parsing. As I talked about earlier, there are different data formats that API uses, And XML is one of the format that is being used to transfer data. But XML is a markup language, just like HTML, and you can add a lot of data in there. Now, if XML has been compromised and somebody added some information that should not be part of XML, and once the server processes that XML and it finds an external link, which is a malicious link, then server can actually go to that malicious link, parse that link and process it and do some action. Now that action may be, download a malware on a server and run it, which may result in compromise of that server. So those are the things that we, that comes through XML, external entities attacks. Broken access control, did we talk about it already? Oh, that was authentication. So access control is a set of policies and mechanisms that ensures users aren't able to act outside of their intended permissions. So there is access, authentication, and then there is authorization. So authorization is what a user can do now. So broken access control is, of course, failure of access control mechanism to properly limit or control access to resources. And that is why when we do web application penetration testing, we always ask for an admin account and a regular user account. And the purpose of that is obviously to verify each and every role function, but also to make sure that the user should not be able to do admin functions without administrator login. There's no privilege escalation that is happening. So those are the type of things that we test using broken access control systems in that application. Security misconfiguration is pretty straightforward. It's when system or applications are not properly or securely configured, and that is one of the weakness in clouds. Majority of the hacks that happen in the cloud with AWS is S3 bucket was not properly set up. Access controls were not there, policies were not there, and data got breached because people who should not have access to that data storage were able to gain access to that data storage because of misconfiguration. Cross-site scripting, you will get some questions, maybe 1 or 2 questions on cross-site scripting. So make sure you have a good understanding of how what is reflected cross-site scripting, what is other types of cross-site scripting. So cross-site scripting is an example of injection vulnerability in a way. So it's a specific variant of injection attack that target web application. So cross-site enables an attacker to inject untrusted code, like a malicious script into a web page or application. When an unsuspecting user navigated to the infected page, the untrusted code is then executed and the user's browser using their permission. So most of these issues are now addressed quite heavily. .NET framework or Java frameworks, those frameworks are now at a mature stage that if you're developing applications using any of those frameworks, you might not see these vulnerabilities. You have seen that SQL injection is not part of this list anymore because SQL injection is pretty much not a valid vulnerability in large part. There might be here and there, but that just like we have eradicated polio from the world, SQL injection is also gone now. So that is a thing of the past. Insecure decellarizations occurs when an application or API takes an untrusted stream of bytes and reconstruct it into a potentially malicious file. So one of the ways that malware masks itself by breaking itself to avoid signature detection and then relying on some later process to reconstruct it. So insecure decellularization can be used to perform a wide variety of attacks and can also lead to remote code execution. So, you break an application into small chunks so that, antivirus or other detecting device do not detect the signature and catch it. And then what happens is when it reaches the destination, it reconstructs itself and executes itself. Sure. Common vulnerabilities during development. So what are those? Those are using components with known vulnerabilities. I think we were talking at the start of this this session, that developer these days, they just go out and copy code from Stack Exchange or other sites like that and use that in their application, which makes their application vulnerable, because most of the time that code, that piece of code, that library is not secure, which basically introduce vulnerability to the application. And that is why mature organizations, what they do is that they maintain their own development libraries, and they instruct their developers not to go out on the internet and use any other libraries other than what is being developed, used, and tested internally on the organization. And organization maintains that library internally. It does not go out, and only developers are required to use those specific libraries. Insufficient logging and monitoring. Again, as the name suggests, if you're not monitoring, if you're not logging your applications, your cloud environment, then you will never know what is happening on your application or in your cloud environment. So we need to make sure that logging is enabled on your applications, how users are using this application, identify events that needs to be critical events that needs to be monitored, use tools like Splunk or any other SIM tools in your organization to collect those logs in case of an incident, so that you can always go back, you can reconstruct what happened, and you can respond to the security incident that happened. So logging and monitoring is very critical in development environment. Anybody needs a break? Do you 5 minutes break, or are we good to go?
We are good to go, man. Carry it on.
Yeah, continue, please.
Okay. All right. So other vulnerabilities are cloud-specific risks. So you probably realize that a great deal of overlap occurs between application security in the cloud and application security in traditional data center environments. So despite the similarities, it's important that you take note of the nature of cloud computing and how cloud architecture contributes to unique risk landscapes. So the CSA routinely publishes a fantastic guide that outlines the top risk in the cloud environment. So I would highly encourage every one of you to go to CSA website. They publish these, just like OWASP publish top vulnerabilities for applications. CSA publishes top vulnerabilities. I think they call it Notorious 19, I think. Like OWASP call it OWASP top 10. CSA call it Notorious 19. So I would highly encourage, go to CSA website or Google Notorious 19, and you will see the issues, most common cloud issues that are out there. And that will give you a very good insight on how cloud is vulnerable, if not properly set up. Quality assurance. So quality assurance in software development is a key thing, is a key activity that needs to happen. Without quality assurance, just like I gave you an example of toy company. I'm sure you have seen in various products there is a QA sticker. Sometimes you will see when you buy something new, there's a QA sticker, and that's basically a quality assurance sticker that somebody in the development process look at that device or that product for quality and put a stamp on it that, hey, it is good to go. So same in the software development, QA looks for mostly perform functional testing. So I've been working with a lot of large financial corporations and other, banking industry, stock exchange. And what I have seen is that the QA is more focused on functional testing rather than non-functional testing. And that is one of our recommendations to them, to introduce a non-functional testing, which is a security testing, as part of QA process. And that is not happening. That is what we are recommending, to use some sort of black box technique, use some tools like IBM Fortify or NetSparker, make it part of, do fuzz testing or fuzzing, of your application, to make sure, you look at some aspects of security when when queuing an application. Okay, so threat modeling. So again, keep in mind, so what we have studied so far, it's what we have seen in development phase of the SDLC. So all of those activities that we have studied, looking at vulnerabilities, looking at QA, these are all development and quasi-testing activities. Threat modeling falls in the SDLC process at the design phase, right? So when you're designing the application, when you are putting together on how the application will function, what are the features of the application, threat modeling comes at the design phase of the SDLC process. And what threat modeling is, and usually the security architects, they perform this threat modeling. So threat modeling is a very manual process. It can also be automated process. There are tools that are out there that helps you in doing threat modeling in an automated way. And then, there are organizations who are doing it in a manual fashion. Let me show you one thing. So Microsoft has a tool that can help you perform threat modeling. So this is the Microsoft threat modeling tool. You can download this tool, and in the threat modeling, you define, you diagram, you identify, you mitigate, and you validate. So these are 5 major threat modeling steps with Microsoft. And Microsoft has its own development life cycle. And majority of organizations are using Microsoft threat modeling methodology. And that threat modeling methodology is called STRIDE. All right, so STRIDE is model developed by team at Microsoft in 1999 to help identify and classify computer security threats. So STRIDE is basically a mnemonic of 6 categories of security threats, right? So these are 6 security threats that makes up STRIDE, their first letter. So S stands for spoofing in STRIDE, T stands for tampering, R stands for repudiation, I stands for information disclosure, D stands for denial of service, and E stands for elevation of privilege. So if you take the first letter of each and every threat, it's become STRIDE. And this is a Microsoft methodology, threat modeling methodology. And what happens is that in threat model, what you do is you look at your application, you diagram it, you develop data flow of that application, then you identify assets. What are the assets? Hold on. Let me show you something, how a threat model looks like. So this is an example of an architecture, right? This is an application. You have your report service, a sample application. You have your data, you have your browser, there's a browser over here, all communication is happening over HTTPS, they're using SOAP API, which is using SSL, there is an FTP connection going into, these are various applications. This is an application server providing different functions, session management, log management, admin interface, and all that. And these are backend databases. So this is a basic structure of an application. Now, when you are doing threat modeling, what you do is you take that same structure and then you identify what are the assets and what are the threats and what are the controls that are implemented. Now, it's the same application based on what we looked at. We looked at A means asset, C means control, and T means these devilish sign are the threats. So basically, you go ahead, you sit with your team as a security architect, and you identify, okay, report server, this is an asset, and what are the controls that are in place? Then you identify a browser as an asset. So these are assets, and what are the threats that can implement browser? And you come up with a report. And that's where, and this is the type of things you come up. So with assets, the A01 is primary DB credentials. So A01 over here is, if we find it, so somewhere here, A01 is. So A01 is our primary DB credentials. A02 is sensitive application data. So we identify assets. And then TA01, what is TA01 is impacting this threat? It can impact A01 over here, TA01. Do you see any TA01? So it's all here somewhere, over here, right? So this is TA01. So basically what I'm saying is that unauthorized external user can impact over here at this level, at communication level. So it's a very brainstorming exercise. You need to understand how, what are assets, what are threats, and what controls you are implementing. And that's how you basically do threat modeling. And this is a matrix that gets generated. That threat agent is TA01. The asset that is going to impact is application username and password. What attack can happen? It will be brute force of credentials. What is the attack surface? That will be browser, right? Somebody can do a brute force attack on the browser. And what is the attack goal? The attack goal is of this threat agent is to get user credentials. And what is the impact? The impact is compromise of user data and any unauthorized, right? And what is the control? What is the mitigation? No controls are in place to prevent a brute force attack other than a simple password policy. So we found out going through this exercise that controls are not in place to prevent brute force attack. So then that's where you basically start designing your application and implementing security controls. And that's what threat modeling brings in. Does it make sense? Or is it too complicated? Okay.
It is fine. Rehan bhai, can you type the link in the chat?
Sure. This page that I was just showing you?
This synopsis for the threat modeling.
Yep. I can do that. Let me find it. Yeah, I'm giving you a much better page, actually. There you go. All right. Actually, I'm gonna give you this. So now, how do you perform this threat model? There are two ways to do it. One is Stride using Microsoft that we just talked about, and the other one is Pasta. So So Stride was developed by Microsoft. PASTA is also another abbreviation, which is called the Process for Attack Simulation and Threat Analysis. That makes up PASTA. Is a risk-based threat model developed in 2012 that supports dynamic threat analysis. The PASTA methodology integrates business objectives with technical requirements, application risk, and attack modeling. So this attacker-centric perspective of the application produce a mitigation strategy that includes threat enumeration, impact analysis, and security. The idea is pretty much the same, as Stride. Basically looking at your application, looking at what is critical, what controls are in place, what needs to be done to improve the security, and what threats can happen, right? So that's the whole idea about threat modeling. And threat modeling happens in the design phase of in the SDLC lifecycle. And once you incorporate these activities in SDLC, then SDLC becomes SSDLC, because now you are thinking about security of the lifecycle, development lifecycle. So the PASTA methodology has 7 stages. One is define objective. Why are we doing this? What is the risk? Define technical scope. What is included? What is the architecture? What technology we are using? Perform application decomposition, looking at various aspects of applications, analyze where the databases are, where the network is, and all that. Complete a threat analysis, which is pretty much the same thing as threat modeling that I just shared the link of. Conduct a vulnerability analysis, model attacks, and conduct a risk and impact analysis. And this is so majority, one of our clients, I have, dealing with clients, and we are actually conducting training for them on threat modeling. And among many clients, only I would say about 2 to 3% of clients are using PASTA threat modeling methodology. Majority of them are, just using Stride. Okay. So the next topic we are talking about is software configuration management and versioning. So configuration management is the process of tracking and controlling configuration changes to system and software, right? Versioning is the process of creating and managing multiple releases of an application, each with the same general function, but incrementally improved or otherwise updated. I mean, we all know what version is, version 1, version 2. So as the version increases of an application, which means you have more functionality, you have better graphics, or whatever the technology allows, or whatever the requirement is, you improve the overall quality or overall functionality of the software in next release version. So in cloud environment where systems freely spin up and down, resources can be rapidly provisioned on the fly. So configuration management becomes an even greater concern for developers. Now, when we do BSIMs, which is in full disclosure, I work for Synopsys. I'm a managing consultant there. And that's why I shared the Synopsys, because that's my company and we do threat modeling quite a bit. So BSIM is what we perform for a lot of applications. So about 2 years ago, the BSIM version that we were doing, it did not have cloud activity as part of BSIM. Now, as we have seen, people are moving more and more towards cloud. We added that activity in BSIM to ask our clients if they are doing any basic cloud security activities, right? Because application development is happening in the cloud. And what we need cloud security. We need to know that they are monitoring their assets. We need to know that developers are just not spinning up machines willy-nilly without any checks and balances, without any configuration management. So those controls are now added. We ask those questions to the organizations that how is your cloud security if they are using a cloud development? So that is a very important aspect now in configuration management. That cloud configuration management is very, very important. so that we can manage those developers and stop them by just creating machines in the cloud without any accountability, right? Because that will increase the attack surface of your organization. So for tracking source code changes, so now from the development point of view, the source code changes throughout the SDLC. Developers can use version controlling tool like Git or Apache Subversion. Subversion is an old versioning tool. Nobody uses that now. Everybody has either moved to Bitbucket or have moved to Git. So both of these tools are open source version control systems that are used by large and small organizations to manage their code development and release it. Okay. All right. Now we're going to be talking about in the SDLC applying cloud software assurance and validation. But these are the activities that happen in the testing phase of SDLC. We talked about design phase activities, security activities, threat modeling is one of them. We talked about activities in the development phase of SDLC. Now we're going to be talking about activities that happens kind of both in development phase, testing phase, and somewhat in deployment and maintenance phase. So these activities are basically happening in three phases. Development phase, testing phase, and maintenance phase. So not all activities happening in all phases, but some activity happen in one phase while other activities happening in another phase, right? And that is, we are adding a layer of security in SDLC to making it SDLC. All right, so functional testing. So functional testing, I think talked about it quite a bit. That is a type of software testing that evaluates individual functions, features or components of an application rather than complete application as a whole. So functional testing is not security testing. So functional testing is considered as black box testing and works by feeding a tested function an appropriate input and comparing the output against the functional requirement. It's as simple. And most of the QAs does functional testing. Now the next is SAST. Now SAST is a non-functional activity. Why? Because it's a security activity. It's not a functional activity. So in SAST, obviously as a developer, and think of that CI/CD pipeline that I talked about. So when developer is writing a code in an IDE, these days there are tools that are available that are checking the code while the developer is writing the code in IDE. The plugins can get installed into IDEs, and they are looking at the code, monitoring the code as the developer is writing. And if it finds, issues like cross-site scripting in the code, or SQL injection, or whatever the things, it will inform the developer that, hey, your code seems to have this issue, you need to fix it. It highlights those issues, right? So this is what we call shifting left in the development process. So if you look at the pipeline starts from left, which is writing the code, and it moves towards the right when it goes into production. So from developer workstation to the production server, it's from left to right activity. So security needs to shift left. What it means that security needs to be start from the developer workstation, right? So that's what shift left means out there. So SAST is basically a static code analysis. So when you write the code, before you compile the application and make it a binary, there are tools like check marks, tools like Poverity. There are other open source tools that are available out there that you can use open source. Let me find a list. I don't know if anybody is interested. So there is this product that we just acquired, Synopsys just acquired. It's called CodeDX. It was somebody else was using this tool, and with this tool, what it does is it has built-in various SaaS and DaaS tools, open source, and it scans your application. And after it scans that application, it takes those issues and it basically creates a dashboard, and it aggregates and correlates all that information, vulnerability information, for developers to work with on and fix those issues. So it has built-in open source SaaS and DaaS tools that you can implement in your development process. So SaaS is basically just looking at the raw code. SaaS is also called what we call a white box testing. So white box testing is where a tester has full access to the code. He can see actually how the code is written. It is not, nothing is hidden from him. So that's what we call white box testing. So SaaS is a white box activity. Then we have DAST, dynamic application security testing. So DAST is a code analysis involved assessing the security code during execution. And in the CI/CD pipeline, I was talking about gates. And these are those gates, security gates in the development. And how they implement it is that developers write the code, they push the code into Git repository, and the Git repository check marks or some other tool like that SaaS tool scans the code. It scans the code and finds that code has high issues or critical issues. Right there and then at that gate, at that checkpoint, the production line stops. The CI/CD line stops. And it basically, until the developer fixes that issue, code will not go into the next phase, which is the build phase. So it has to, then code gets pushed back to the developer fixes those issues, it gets scanned at the gate again, and then you go into the build process. And these are the gates. I mean, just like you go to the airport, right? You have to pass through the security. If you do not pass through the security, maybe you have a belt on with a metal buckle or something in your pocket, what they ask you, go back, step back, get your belt off, or get whatever the metal object you have, put it in the bucket, and then come back. So that's the checkpoint. That's the gate I'm talking about. So in the software development, these are the gates, security gates. DAST is basically, in the pipeline, people use tools like Gispp proxy. So what it does is basically you still have an application in a very crude format. It checks the application in a runtime format. It looks for OWASP top 10 types of issues using DAST tools. And if there's any issues, code stops. It goes back to the developer. Developer needs to fix it. Then it goes to SaaS. It goes to DAST. If it passed, then it moves into the next phase. In the next phase, maybe a vulnerability scan is performed on the infrastructure where the code will get deployed. So that's where you might use tools like Nessus or Qualys at that stage to do a vulnerability scans on your systems where the code will be running. And the last stage before you go into the production is penetration testing. Now, there is a difference between DAST and penetration testing and vulnerability scanning. So you need to be very clear on that. Penetration testing is, so let's talk about DAST first. DAST is very loose runtime tests happen very at the early stage of development when the build process initially happened. There is no manual testing. There is not in-depth analysis. It's just an automated tool and find the low-hanging fruits in terms of vulnerabilities. Penetration testing is more involved. It basically, when a person or a security team has full access to the application, they have credentials, they can log in, they can run automated tools. And in addition to those automated tools, they also do manual analysis, manual testing of the application, more in-depth analysis, and find issues. Now, if an application process goes through all these security checkpoints, then you have a much better chance that your application is very secure when it gets deployed into production. But the reality is quite opposite to that. This is the same struggle I talked about. Developers do not like these checkpoints. They want their code to be in production. And then there's a problem of critical products, right? Businesses want their software products to be in production as soon as, because they want to make money, right? So, and sometimes just-in-time deployment, if security is not there, then we have issues. So this is a very, it's a kind of a fine dance that happens in the company, in the organization, where security versus functionality, business people versus security, software developers versus security, they all are like, they're not very happy with each other. Make sense? Okay. Next one is using verified secure software. So, one way to, improve the overall quality or software security quality of your organization is to use verified softwares or libraries, right? And approved API interfaces. I talked about, libraries that manage, organizations maintain internally, so that they are vetted, they are verified, they are good security libraries with less of the security issues. So use those. So use APIs that are tested to ensure that they are appropriate. I mean, for example, let me give you an example. So one of our banks that I'm working with, and one of my clients, they're working with a retailer. So that retailer can use that bank's credit card. Now, retailer has their own website. Now, if anybody wants to apply for a credit card from that retailer's website, they have to, apply for a credit card. So when they apply for the credit card, that information goes to that financial institution. And now that retailer website and the financial institution credit card website are linked through an API. Now that API needs to be very secure, right? If it is not secure, then there are chances that sensitive information like credit card numbers, social security numbers of that retailer customers can get compromised. So we do testing of their APIs, and they are using REST APIs. So the testing is basically just like any other type of penetration testing that we do for web application testing. Supply chain management. I'm sure we all heard about SolarWinds hacks. So that was a big attack that happened due to supply chain issues. Supply chain is basically how many people or how many suppliers are involved before the final product gets delivered to you. So in case of SolarWinds, there were some libraries, or there were some, whoever the person was, a developer, they left a hard-coded password in there. And that hard-coded password, since SolarWinds has lots of clients using the same product, government institutions, financial institutions, healthcare industry. So since the supply got compromised, or supply was not very good, it was below quality, that same password, hard-coded password, get distributed with the software to all their clients. And once a hacker find out, or a malicious user find out that this was the issue, everybody who was using that software was vulnerable, got vulnerable. And that was a supply chain attack that happened because the supplier did not do their due diligence in making sure that their software is a quality software and it has no security issues. And that's where now organizations are more focused on vendor assurance program. Now, what vendor assurance program is that if I, as an organization, wants to hire somebody to develop a software for me, I hire contractors, or if I actually buy a software from somebody, I need to make sure that that company who I'm considering to be my vendor, who will supply me the software, have similar security requirements or better than my organization, so I can rest in sleep peacefully that the purchase that I made meets the security requirement and it will not create an issue in my organization. So vendor assurance programs are quite in. I am actually developing a vendor assurance program for one of my clients. So we are looking at various aspects of it just to address the supply chain management issues. Third-party management, software management. So when supply chain management is focused on securely managing your use of third-party application, you should assess your organization's use of third-party to manage parts of your software. So, you need to make sure. So there are two aspects of it. You are asking somebody to develop something for you, which is customized for you, or if you're buying COTS product. COTS means COTS. It means custom off-the-shelf product. Like Microsoft Office is a COTS product. And I'll write it over here, custom off-the-shelf. So it is, so now we need to make sure, what's it called? SolarWinds. SolarWinds was a COTS product. It has an issue, right? And I need to make sure that that organization is issuing patches. It is updating the encryption algorithm. It is making sure the access management is properly set up. So supply chain management, third-party software chain management, these are all part of the verified software solutions. This is pretty basic. We talked about it before. We just skimmed through quickly. So comprehending the specifics of cloud application architecture, we need to make sure in the cloud architecture we have firewalls. We all know what firewall does. Then for web applications, we need to have VAPs, web application firewalls, and these firewalls protect against basic threats like OWASP top 10. So you implement web application firewalls for your application. Malware and threat protection, we all know. We need to make sure cryptography is central component of your cloud computing. Again, all the data is communicating over untrusted network, which is the internet. So we need to make sure HTTPS is enabled, which is for data in transit. We need to make sure data at rest is encrypted, which is basically database encryption and all that. And then sandboxing. So sandboxing is a process of isolating an application from other applications and resources that are placing in a separate environment. So by isolating an application, errors or security vulnerabilities in the application are also isolated within the sandbox, thus protecting the rest of the environment. So I think we talked about Dockers in the past, we talked about containers. So those are sort of sandboxing technologies where you are isolating the application from the rest of underlying operating system architecture. So if anything happens, it is happening in that sandbox environment, and it is very easy for you, if something happens, to isolate an issue if it happens. So, and sandboxing provides isolation basically. Okay, so application virtualization and orchestration, we talked about it at length in our last chapter. I think we can skip that. We all know what virtualization is. We all know what application orchestration is. We talked about, again, Docker is an orchestration, Kubernetes is an orchestration platform, and Dockers are the ones that create containers, which can be managed through Kubernetes orchestration engine. Designing an appropriate identity and access management. So this is kind of important. You will get some questions on what is a federated identity, what is SAML, and what is OAuth. So all of these things kind of work together. I think we have one more slide left. Yeah, two more. So federated identity means that, multiple organizations, they trust each other. They trust each other access management systems, and users of one organization can access resources of another organizations without being part of the other organization. So that's what we call federated identity. So users or systems identity on one system is linked with their identity on one or more other systems. So usually, for example, let's take large government departments. So users in one government department can access resources in other government department. Although they are not working for their department, they do not have a user account on their system. It's just basically the identity management systems are linked together. And that's what we call a federated identity. So how that federated identity works, the underlying working mechanism, one of the components for federated identity management system is SAML, which is security assertion and markup language. And this language, basically, you define how that trust is established, how the resources are being shared, how the users can access to certain resources. All that is written using SAML language. So SAML language is a part of federated identity management system. Then we have OAuth, which is an open standard that application can use to provide client with secure access delegation, right? In other words, OAuth work on HTTPS and issue tokens rather than using credentials. So obviously, obviously one user who is member of organization A and not member of organization B, he does not have username and password in the organization B. So OAuth facilitates that by using tokens. So so you might see OAuth in action in application like Google or Facebook, which use OAuth to allow you to share certain information about your account with third parties using share your credentials. You must have seen, you add an application and it allows you to log in using your Google account or your Yahoo account or your Facebook account. All of that authentication happening, third party, is using this OAuth standard. Single sign-on, we all know, is basically you sign on once and you have access to all resources after you sign on. And that's what single sign-on in a nutshell means. User only have to sign in once. And once the user log in, he can access any of the resource. He does not have to log in individually to access each and every resource in an option. So it's more of a convenience when you do single sign-on. Multi-factor authentication, again, as the name implies, we use 2 or more authentication factors, what you know and what you have. So what you know might be your password, what you have might be a token, it might be a biometric or a soft token or a hard token or something, Microsoft Authenticator app on your mobile phone or Google Authenticator app on your mobile phone. If all of you are not using those 2-factor authentication on your mobile phone, I would highly recommend to implement 2-factor authentication on your Twitter accounts, your Facebook accounts, your Google email, Yahoo email, Outlook, wherever 2-factor authentication is available, you should enable it and you should install 2-factor authentication on your mobile phone and use that. The last one is CASB, Cloud Access Security Broker. So these components sit between cloud users and cloud, and organizations control them. And what CASB does is just provide visibility into organizations' cloud usage, including who uses which cloud application from what device. So it's a broker, right? So what that broker means, brokers always sit in the middle. So it's a broker. So just like a property dealer is a broker, he is between you and the seller, right? So that broker basically does all for you. So that's exactly what Cloud Access Security Broker is, just a broker between the user and the cloud environment. Then it provides cloud security, monitor the security of data owned and operated by organizations. So CASB can help prevent data exfiltration through cloud services. It provides threat protection, and it also helps you in meeting compliance requirements. So I think that's the topic for today. Any question before we end this call?
Rehan bhai, I have a question. I just wrote it somewhere. Yes.
Sure.
There, when you mention SOAP and REST, there you mentioned 3 languages which goes under REST, which is YAML, XML, and JSON. How about the other language?
These are data formats. These are data formats.
Yep, sorry. So how about the other data formats like CSV or TOML or the other one, whatever remaining?
Yeah, those are not very portable formats. These are JSON, XML, and YAML, what we call, मैं echo आ रही है अगर आप mute कर लें तो. So these are called portable formats. So XML, YAML, and JSON can be converted into CSV. Microsoft Excel has the capability of reading these data formats and converting them into CSV. Any other questions?
Yeah, Rehan Bhai, I have a question. This is Sayyid Atif from Houston. Thank you for doing this. First of all, I'm tuning in first time. So my question is, you mentioned CASBs, right? And these are right in the middle between the enterprises and the cloud, correct? But what shift are you seeing? I mean, I'm working with Netscope as a CASB provider, and they talk about SASE concept. Again, they want to sell the CASB, but you have mentioned a whole lot about the data security or the security within the cloud. So they are pitching in saying GRE tunnels, into our CASB, and we'll take care of everything, access control and whatnot. Where do you see this shift going? That's my question.
Well, I mean, I think what you're mentioning is a third party coming in and providing a CASB solution, right? They establish a GRE tunnel into your CASB, and they are saying, hey, enterprises, you don't need to worry about your CASB solution. Let us manage it for you. That's what they are essentially doing. But if organizations have capability internally of managing CASB solutions, like Microsoft CASB solution is being used quite a bit, I have seen with my clients at least. So they are managing it by themselves. There are organizations, they want to implement CASB, but they do not have internal expertise, right, to manage CASB, because you can do a lot with CASB. So then, they can reach out to third-party service providers and have them manage their CASB solutions. So CASB is there. I'm not sure if I answer your question, but it depends upon how organization is set up and what resources they have.
Yeah, partly you answered. I mean, my question, enterprise you answered, but my question was more, is the SASE concept, with the CASB, meaning the third-party provider, or is it shifting more toward the cloud, where data at rest, data and use, and data,
It is very much shifting towards the cloud. It is.
Okay. Okay.
Yeah.
Are there solutions out there where they can actually do all of this, what CASB is claiming?
CASB is just a general term. Microsoft has its CASB solution. I think there's a Cloud9 that is also a CASB solution. So there are third party out there. I think that was developed by Citrix. So users are using, and Cloud9 is, I think, now called Cloud Dome, I think. So yes, people are using either Microsoft or Cloud Dome solution.
One thing here, it was mentioned just recently that the CASB is offering GRE tunnels. Is this what you said? They are offering GRE tunnels?
Yes.
So why not IPsec tunnels? GRE is like just simple payload, right? It's prone to attacks. Maybe
they are encapsulated in VPN connectivity, right? In VPN tunnel. So the traffic is definitely
GRE inside IPsec.
Okay. Yes, exactly. Okay. Yep.
Okay.
So you have to have secure communication. Otherwise, there's no point of just having a GRE tunnel without any security. Right.
Just because IPsec itself is a tunnel, so I'm not sure why GRE inside IPsec. But anyways, one thing about this integrated development environment, I mean, does it has anything to do with the Terraform thing? I mean, IDE.
Yeah. So Terraform is basically a language or a scripting language that basically helps set up the production environment in the cloud, right? So what developers are using is usually what I've seen is that infrastructure people, they write that code and give it to developers. So when developers need to spin up an environment with their code, they also send Terraform code with that. So Terraform code basically sets up their environment, and then they can push out their code for testing. But the problem sometimes comes in that if it is not properly managed, since Terraform which is called infrastructure as a code, developers can modify parameters in there. And if they modify the parameters, then they might introduce security issues in that environment.
And when they say, okay. And when they say infrastructure as a code, that means it includes the virtual firewalls and switches in between, or just the reference of the servers and the Windows that is running on the server?
It could be both. It could be software-defined network, SDN. That is also part of infrastructure as code, because as I mentioned, everything cloud is virtual, right? So you can set up, so SDN networks and obviously physical server or environment, both can be part of infrastructure as code.
So I'm not sure if the developers can work well with this SDN thing. I'm not sure really. But
some are smart. Some developers are
because
smart.
I was thinking about switching loops and this sort of stuff. Maybe they mess up with their environment in that.
Yeah, I mean, for one of my clients that I'm working with, they actually really control infrastructure as code. So developers are not allowed to make any changes to it.
Okay, because I was thinking maybe they have a virtual server that is connected to a virtual switch and then a virtual firewall and things like that. Just for, I hope you're getting my point, right? Yeah.
Yep.
Yeah. Okay. And I think I confused the integrated development environment with the Terraform. So they are different things, right?
Yeah. So
Terraform is a totally different thing. Yeah.
Yeah, Terraform. I'm sure you have heard about Ansible. There are Vagrant. So there are Salt. So these are all infrastructure as code tools that can be used to set up an environment. So you can, managing and provisioning of computers. So all of these languages, they are very smart. They are very developed. You can use them and set up your provisions and environment.
Okay. Thank you very much.
Rehan bhai, the last question from my side at least.
Sure.
When we are talking about the cloud vulnerabilities, where you mentioned the cloud vulnerabilities, the underlying technology can be a part of it or no? Like, as I know, VMware itself has some vulnerabilities issues. Microsoft itself, their virtualization have vulnerability issues. So if they are using it as a backbone, so it's not mentioned, I think.
So it is, it is, right? If you remember, the cloud is a shared responsibility model, right? So that part, virtual machines or underlying physical infrastructure, is the responsibility of your CSP. So they're responsible. So if they're not taking care of it, then obviously that will contribute to overall cloud vulnerability.
Consider I'm using a private cloud, then?
If you're using a private cloud, then you are responsible for that. If you're hosting that cloud infrastructure. Okay.
Okay, sir. I think let's close the session now. Thank you, everyone. Right. Thank you, Rehan bhai, for the domain 4. Now we have 2 domains left, inshallah, and then we'll close this topic. Okay, Rehan bhai, one question. DevSecOps. What is DevSecOps?
So DevSecOps is a culture.
Partially in this section, this topic also today, it was there? Or?
Yeah, we talked about DevSecOps, and I mentioned that DevSecOps is nothing but a culture on how development teams works with operation teams and how security lays on top of it. It used to be just DevOps. Now with the integration of security, it becomes DevSecOps.
Somebody was asking me to do a session on this one. So I was thinking, what could be there, in DevSecOps. Maybe a discussion can be done.
Go ahead.
Okay. No, not now, but maybe some other time we may do a session on DevSecOps or something.
Sure. I mean, this is basically, if you look at it, from the SDLC point of view, right? If you look at this diagram, so you have your plan, you code, you build, you test, and then you release. And deployment, operate, and monitor, and then it feeds back like this in an infinity loop. And on top of that, you implement security. So again, it's a culture. It's not something that it's not a methodology. It's not anything else. It's just how these teams are working together.
Maybe the person who asked me, maybe he wants to implement in his organization, you know.
Okay.
Maybe that's what he's asking.
It's a culture that needs to be developed.
Okay, guys, we'll close the session now. Thank you, Rehan bhai. Thank you, everybody, for attending.
All right.
Thanks a lot. Very good session, Rehan bhai. Thank you very much.
All right. Thank you very much. All right.